Okay, so in this second tutorial, we're going to be looking at inelastic two-dimensional collisions. It's a walkthrough, meaning that I'm going to take you through how to solve these types of problems step by step. If you've done the first one, the two-dimensional elastic collision walkthrough, then you basically could do this one on your own. But just for completion, I'll do it with you. Now, you follow the same procedures, recognizing that momentum is always conserved both in the x and the y direction. So one of the first things you can add to your little diagram here is a positive x direction and a positive y direction. So x and y, like that. Now, what we've got is a dump truck coming this way and a car coming this way. They hit, and it's inelastic, meaning they stick together, collide, and then they fly off in this direction here. Now we're given the information for the mass of the dump truck. It's 3,000 kilograms, and the car is 800 kilograms. Now this one is moving at 15 meters per second in a purely eastward direction, and the other one is moving at 32 meters per second in a northward direction. Now, if you just look at the total momentum of both of these, the first one for the dump truck is 3,000 times 15 is 45,000. And the other one is 25,000. So this one's carrying about 26,000 kilogram meters per second of momentum. And this one's carrying 45,000 kilogram meters per second of momentum. So even though this one's traveling faster, this one still is carrying more momentum. That means that when these two hit, they're most likely going to go at a more shallow angle, right? They're not going to be going off in this direction. That makes sense. The one that's carrying the more momentum will be the most of the direction of that momentum that's carried on. So it says here that it basically wants us to figure out what is the speed and direction. So we're trying to find the final speed as well as the angle at which they move. Now we know the angle is going to be less than 45, most likely, because this is carrying more momentum than this. If they were carrying the same amount of momentum, we would probably think that it would be about 45 degrees that they would move off at. And again, you can test all these analyses as you work through different problems. So let's do the walkthrough. Determine the total momentum in the x direction and in the y direction. So let's look at the first object. Its x momentum is this 3,000 times 15. So this is 3,000 is the mass times 15, which is 45,000 kilogram meters per second. P2x, well, this object, so this is going to be mass 1, this is going to be mass 2. P2x, if you look at it, there is no momentum in that direction. So it's 0. So that means that the initial x total momentum is simply 45,000 kilogram meters per second. That's all there is. That's all the eastward momentum. In the y, so this one here has no y momentum, and this one here is carrying all of the vertical, the y direction momentum. So we go 800 times 32 is 25,600 kilogram meters per second. Okay, so now we know the total y momentum and the total x momentum, which means that after they collide, they have to have the same amount of total x momentum and same amount of total y momentum. So based on the law of conservation of energy, conservation of momentum, the final momentum in the x had better be that, and the final momentum in the y had better be that. The two become entangled after the collision, so we can assume that the velocities of the two cars are the same and the masses are combined. So in this next part, we're going to say, okay, well, what we can do now is realize that there's going to be a final speed and that the total mass is going to be m1 plus m2. Okay. Use Pythagorean theorem to find the resultant momentum after the collision using the two components from step 2. Include a diagram. So we look at step 2, and we know that the total momentum in the x, so we go like this, we say, well, the total momentum in the x final and the total momentum in the y final. And then we are going to end up with our resultant, which is the total final momentum that you can see here. Okay, well, this we know is 25,600. And since, this is vectored, since these are vectors, we've been dropping the vector signs a lot, but since they're vectors, we know we can just add vectors tip to tail to find the resultant. There we go. So we go 25,600 squared plus 45,000 squared. And then we just simply find the square root of that, and we find that the total momentum is approximately 51,772 kilogram meters per second. So that's the total momentum. And if you recall, that's actually the total initial momentum as well, right? So we know that that is the same thing because conservation momentum says that they must be the same. All right, so how does that help us? Well, it says determine the angle. So the first one we're going to do is determine the angle theta. And so from our diagram, we know that the tangent of the angle is the opposite, which was P, I think it was PYF over PXF, opposite over adjacent. And we know that that's simply going to be 25,600, if I recall, over 45,000. And then we do the inverse tan of that. So 25,600 divided by 45,000. And then we do second function tan or inverse tan. We get 29.6 degrees. There we go. It's about 30 degrees. And we knew that angle was going to be shallow. We knew it wasn't going to be more than 45. It was going to be under 45 because the dump truck was carrying the most of the momentum. So using your steps, your knowledge from step 4 and 5, determine the speed and velocity of the two vehicles. Well, since they're stuck together, we know the angle is 30 degrees and 29.6 degrees. We know that part. But for the second part, it says, let's find out the speed and direction. Well, remember that momentum, the final momentum, is the total mass times the final velocity. Okay. Well, the total momentum was 51,772 divided by the combined mass. And this here's the M1 plus M2. And the two masses were 3,000 plus 800. So the combined mass is 3,800 kilograms. So 51,772 divided by 3,800 is 13.6 meters per second. So the final velocity of those two objects is 13.6 meters per second at an angle of 30 degrees. Okay, and again, you can justify that the two objects would have slowed down. One was going 15, the other was going 32. So the truck slowed down less, and the car slowed down quite a bit more, from 32 down to 13, and they travel at that angle of 30 degrees. Okay, so some of the key points here is that when you're adding momentum, momentum can always be added up as a diagram because they are vectors, and just like we've done before with lots of vector work, you just add vectors tip to tail. And by adding them tip to tail, you can find the result by just doing Pythagorean theorem. If there's one, you can use Pythagorean theorem, cosine law. If you start to get multiple ones, you'll have to draw a scale diagram or break the entire thing into components, which is ideally the best way to do things. Okay, so now you're ready to tackle some of the problems in the assignment, and I would encourage you to start trying those. I'll post a couple solutions to those as well, video solutions, so you can check your work and see if you're on the right track. All right, good luck.